Another very common way to indicate a set is to use ordered pairs. So let's recall what an ordered pair is. We have a list. It's a list of two things, numbers, usually, in which case, as the name implies, the order does in fact matter, and repeats count. Okay, so we have that these two pairs, say 1, 2, and 2, 1, these are not the same. These are different. We wrap ordered pairs in parentheses. So when I say repeats count, 1, 1, 1, 1 is unique. 0, 0 is unique. Let's look at a set of ordered pairs and see if we can decide if this is or is not a function. I'm giving you this set here. It is the set containing the ordered pairs 1, 1, 2, 3, and 3, 3. Now we're dealing with a set of ordered pairs. The domain is always going to be the set of first coordinates. With ordered pairs, we speak of coordinates, right? First coordinate clearly is the first one that appears. Second coordinate, the second one that appears. So the set of all first coordinates is my domain. So I start by opening a set, and then I'm just going to pick out the first coordinates. So 1, 2, and 3. So my domain set is the set 1, 2, 3. Range. Okay, well, I mean, if the domain was the set of first coordinates, what do you suppose the range is? If you said set of second coordinates, you're absolutely correct. So open a set and have a look here. I have, let's see, 1, I have 3, and then I have 3 again. But because this is a set, I do not need to rewrite that 3, just need to write it once. Right, next we want to confirm, is this a function? We know what the domain is, we know what the range is it a function? Well, let's see. Does every element in the domain have a mapping? Let's see, 1 has a mapping. Yes, 1 is mapped to 1. That's what this ordered pair means. 1 has been mapped to 1. 2. Let's see, 2 was mapped to 2 is mapped to 3. And 3 was also mapped to 3. So yes, part 1 of our definition has been satisfied. Every member of the domain has been mapped, so it has some corresponding member of the range. 2, I want to know, does each member of the domain get mapped only once? How do I figure that? Well, I just look. Notice I have 1 appearing once here, 2 appearing once here, 3 appearing once here. I have no repeats in the domain. So no repeats in the domain. So no repeated first coordinates. Then I'm satisfied. Yes, we have a repeated second coordinate. You'll notice this 3 is used twice, but that's okay. My definition does not say that the range cannot repeat. It simply says the domain cannot repeat. So this is a function. All right, let's consider this next example. There's another set of ordered pairs. I have the set 1, 1, 1, 3, and 3, 3. Let's do the same thing. Let's find the domain. Let's find the range. And let's decide if this is a function. Oh, the domain is the set of first coordinates. So I have 1 here. I have 1 again, so I don't need to write it down. And I have 3. So 1, 3. The range will be the set of second coordinates. I have 1, 3, and 3 again. So in fact, my domain and my range are the same. Is this a function? Let's see. I've got 1 mapped to 1. I have 1 mapped to 3. And I have 3 mapped to 3. So every member of the domain has been mapped to some member of the range. So the first part of our definition is a check mark. Every member of the domain has been mapped. Second part is every member of the domain mapped just once. So let's say I have 1 here and 1 here. I have a repeat in the domain. So 1 appears twice as a member of the domain, which is a no-no. Should be mapped only once. So this is not a function. All right, we can also indicate a function using a diagram or a chart of some sort. In this case, I have the bubble diagram. My domain usually will be the left column and the range the right column. In this case, I've indicated those. So here's our domain. It is the set 1A, 5, -12. And if it's a mixture of letters and numbers, that's fine. Our range, it will be the set TR, -9, and 4. All right, let's see, is this a function? Well, let's see, 1 is mapped. And I'm just going to follow the line here. It's mapped to -9. A has been mapped to T. 5 has been mapped to R. And -12 gets mapped to 4. So every member of the domain has been mapped. We can see that from the chart by just checking to see if each member of the domain has a line, an arrow, or something indicating that it's getting mapped. So yes, each one has a mapping. Does it have only one mapping? Well, let's see. Is there just one line here? One line, one line, one line, one line. Yes. Everyone's been mapped. Everyone's been mapped just once. This is a function. All right, let's consider this one. Is this a function? We'll go through the same thing. I've got this domain. It is 1A5, -12. 1A5, -12. Here's my range. My range says it is TR and -9. Notice that my domain is larger than my range. That's okay. I'm still just going to check. Does each member of the domain have a line? There's a line, there's a line, there's a line, there's a line. Does each member of the domain have only one line? Yes. In that case, this is a function. In pink this time. Are we concerned about the fact that T gets mapped to twice? A maps to T and 5 maps to T? No, I'm not concerned about that at all. Again, the definition of a function doesn't say anything about whether or not my range values can repeat, only my domain. So this is still a function. So what would it look like if something fails to be a function? Let's look at this one. I have the domain 1, -1, 2, -2, and the range 1, 2, 3, 4. And I go through and I check, okay, you see 1 has an arrow, -1 has an arrow, 2 has an arrow, -2 has an arrow. But in this case, I've got that 1 has 2 arrows, right? And 1 is being mapped to 2, but also to 4. So that breaks it. Why? Domain must get mapped just once, not a function. Why? 1 gets mapped twice. What's the other thing that can go wrong? Well, here we go again. My domain is still 1, -1, 2, -2. My range this time is ABC. Notice that 1 gets mapped, -1 gets mapped. 2 is not mapped, -2 is mapped. So here we have a problem. We have a member of the domain that is not paired to a member of the range. So that is not a function. 2 is not mapped.